Hello, this is Sirisha Kisra. My class ID is 14. Coming to the icp6 of deep learning, it is based on autoencoders, which actually take an input image and encode and pass it to the model, and the output before the output layer it is a decoding. The output layer would be a decoding layer which decodes the encoded image and produces the actual input that we have given. Coming to the icp, we need to add hidden layer to the source code that is provided in the autoencoder. So let me walk you through that. So here initially there are no hidden layers, so I've added an hidden layer of dense 64, taking the input image shape of 784. Here encoding dim I've taken as 32, and there is a encoded layer which encodes the input image that is given to the hidden layer, and that hidden layer output passes to the is given to the encoded input. And there is another hidden layer which takes the output from the encoded, and for the decoded we are giving the input of the hidden one. And finally in the autoencoder we are creating a model of input image that we are taking in the decoded layer. So, and while we need to first compile it using optimizer and binary cross entropy loss function and metrics. We are giving accuracy here. So we need to perform this on fashion MNST data. So we are loading the data. Here we don't need the labels for this data, so we only need the images. So we are only considering the images, train and test, and we are reshaping them, converting it into float and reshaping them. And we are finally training using the train images, and the validation will be on the test images. So we are predicting the input of the first images of the set that we are giving of the X test. So basically normally we are taking the input that is X test of 0, and the prediction would be autoencoder model that we are giving and predicting using X trans. Here X trans is nothing but the X first image of the so in the prediction it will give the reconstructed input, and we are printing the input and reconstructed input, and using the history object we are plotting model and loss, model accuracy and model loss. So let me run this code. So as you see, the accuracy we got is 0.5 and the loss is 0.3. So we are plotting first the input is this, so, and the reconstructed output is also similar. The model accuracy of the train data and the test data, and the loss plot. Going to the denoising autoencoder. In the denoising autoencoder, we add a noise to the input, which actually passes the noise input to the model and predicts the actual input. So here the remaining part will be the same. Here we are adding a noise factor to the input, explain plus this noise factor, and to the autoencoder model we are training it using the noise images and the actual train images, and here I'm plotting the input image of the 11th image of the X test, and noisy input. The noisy input will be the noise train images of the 11th image in the noise train set, and the reconstructed representation we are getting it from the autoencoder model. So prediction, we are taking the input image from the autoencoded model. So, and also plotting the accuracy and loss using the history objects. So let me run this code. Accuracy we got is 0.5 and loss is 0.3, and the input image In the noisy input, it adds the noise to the input image, and the reconstructed representation of the input is this: the model accuracy plot and the model loss plot. Thank you.